Hello everyone, welcome to my stream, and today we are going to solve LeetCode daily problem. So let's read the problem. It says n repeated elements in size to an array. So basically, let me just open XLE draw. Sometimes I just think, why do I even use a laptop? Okay, let's erase it and go ahead. Mhm. So n repeated elements in a size of array to n. We are given that there is an array. In this array, we have n plus 1 unique elements, and there is an element which is repeated n times. So let's just say if we have an array of size, if our n is 5, that means we have 10 elements in array, and 5 would be repeated. Any number in that would be repeated 5 times. Let's just say 1 is that number repeated 5 times, 2, 3. I can just type it out. Okay, let's just make an array 1, 2, 3, 4. Let's just repeat 4 5 times. 4, 5, 6, 4. 1, 2, 4, 4, 4. And there should be 10 elements exactly. 1, 2, 3, 4, 5. Okay, so now we have 10 times. We have an array of size 2 times n, where n is 5. Let's just say if our n is 5, then our one number, that is 4, is repeated 5 times. 4 is repeated 5 times. And nums contain n plus 1 unique elements. Exactly one element of nums is repeated n times. Why does it contain n plus 1 unique elements? Okay, it contains n plus 1 unique elements because the 5 n elements are distinct. N elements are distinct, plus 1, this which is repeated 5 times, is also distinct but just once, so n plus 1 distinct elements. How can we solve this problem? So whenever such problems are given to us, we can always think of, whenever we have repeating stuff, we can just think of a hash map, which is very basic thing. Everybody uses a hash map. Whenever we have to detect if any number is getting repeated, we can just store the values and check out whichever has a number greater than n, or we can just use a frequency array of size n plus 1. And in that frequency array of n plus 1, we can increase the frequency. Oh, I don't think a frequency array would work because it's not 1 from 1 to n. Yeah, so we can just use a hash map, but there has to be some way with which we can solve this problem in O1 space complexity. And how do we do that? So there is a pigeonhole concept that whenever numbers are given in such a manner like this, then there are very high chances that whenever we have one element repeated half the times, then there is a higher possibility that this number would be at max two distinct numbers away. So whenever we are mixing up number, this is a concept of randomization. So that's a concept from probability. Let's just try to understand that concept. Out of all these numbers, what are your chances of picking up a number that is this repeated number? There is half the possibility. So in this pigeonhole concept, that this number would be repeated at least once, Have you heard of Moore's algorithm? You can use Moore's algorithm as well, but that would not work because Moore's algorithm is designed for something where the number is majority, like more than n upon 2 times. So here we cannot use that because our number is not repeated by more than n upon 2 times. Why am I even teaching at this point? Okay, let's. So using this pigeonhole concept for int I equal to 0, I less than nums dot size I plus plus, what do we do? So whenever we encounter such kind of windows, we are going to check in a window of 3. So in a window of 3, if if we found any number equal or any number which is repeated, we will decide that if any number is repeated, since all the numbers are distinct, so if any number has been repeated, it means that this is the number which is repeated. So let's just say if nums of I double equal to nums of I plus 1 or nums of I double equal to nums of I plus 2. Oh, I think we are not going to traverse that much, so I can just put a minus 2 here. Or let's just say nums of I plus 1 is equal to nums of I plus 2. If we find any two similar elements, we will return that number itself. We'll return nums of I. If if this is not, since our randomization theory says that it has to be at least at max 2 digits away. So if in a window of 3, let's just say this is the case, let's just say this is the case, and if our array was just this long, then in such a case, what happens? Num dot size minus 1. The last one, let's just say if it works or not, let's run it. Okay, it's not working. I think I should not match this one. We just have to match this. Uh-huh. Let's check. Okay, that got accepted. So our first problem for the day is done. I think we can just make a note of this, LeetCode daily. And there are no pages inside. What is the question number? LeetCode 961. Mm-hmm. My explanation was too bad. If it was, then just move to another channel. I don't give a damn. Yeah. Okay. Now let's write down the approach that we have used to solve it. We have used the theory of randomization. Oh, never mind. We can just make the notes later on. Uh-huh. Uh-huh. Let's do some binary search problems. I feel bored of that anyways. Binary search. I have solved four problems from binary search. Ah, I just got distracted for a minute. You shouldn't talk to guys. Count them with tree nodes. I haven't done trees yet. Intersection of two arrays. Intersection of two arrays. Two. Let's check what kind of problem is that. What does the problem says? Return an array of their intersection. An array of their intersection. Each element in the result must be unique and you may return the result in any order. Okay, so what do we have to do? We have, hmm, what is the time complexity needed? Does it have to be in n log n? You have to return the array of the intersection. Hmm, very new problem. What I can do, I can just binary search the numbers in both the arrays if it is already present. Is it sorted? Find each element in the result. I can do it, but I would do it in O n square complexity. Two pointers. It can be done by two pointers as well and binary search too. But how? How can it be done by binary search? At this point, I feel like I don't even know binary search. Valid perfect square. Let's try this. Hmm. Hello, Akash. Wait, did you just send it now? I was gone for some time and then you just came up. Anyways, so our problem is valid perfect square. Given a positive integer number, return true if num is a perfect square or false if otherwise. Okay, so if a number is a perfect square, we just have to return true. And if it is not a perfect square, we have to return false. So I guess we can use the same logic that we used last time. Hmm. So what do? We take an int low equal to 0, int high equal to num, and now we run a while loop. While low less than equal to high, we calculate a mid, int mid. Oh, I guess. No. We will calculate a long square. If, and how do we calculate it? No, we calculate a mid. Int mid equal to low plus high minus low upon 2. And then we do hello Akash if you're back. I don't know who is watching, if it's you Akash. I see you. Okay. Now we calculate a square, which is going to be a long square. And how do we calculate it? We calculate it by doing mid multiplied by mid. So now our first condition, if the square, oh, mhm, if square double equal to num. Can you hear me? Who is it? Whoever is on the stream, just say a hello. There are two people watching. Who is the other one except me? Anyways, let's get back to it. Okay, so if square equal to num, we know that it is a perfect square. We will return true. But if the square is bigger than num, that means we have to go a little smaller. So what would we do? We will change the low. We will change low equal to mid minus 1. Why are we doing minus 1? If I don't do minus 1, then it will become an infinite loop. And I can just write an else here. It just looks good for the aesthetic purposes. It won't change anything anyway. Because the function is getting returned from the previous line. If it is less than num, what do we do? That means we have not received. We can just return false. Let's try what happens. It's a game of try and error at this point. If the test cases fail, then we will curse the god together. Oh, I haven't changed the high. As a square is less than high equal to mid minus 1. You could have reminded me of it. Sometimes I seem to forget binary search and very basic stuff in that. Still time limit exceeded. Why? Why is it mid plus 1? And this should be mid minus 1. So many errors. And an easy problem. That's my level in the DSA and I dream of going into a monk. God. Why am I returning false? If it's not true, then I'll just return true. Who cares? Oh. The last case should be false. If the number is a valid perfect square, I'll just return true in both the cases. We return false because this is not an integer. What are we doing? Oh, it should be false. This much is clear so far. If a square double equal to num, it's returning false. Why? I think the problem is in line number 9. If a square is equal to num, that means number is a perfect square, right? It's very simple. Then it just return true. When we calculate mid, oh, if a square is bigger, then we change high. And if this was completely opposite, I should just commit suicide at this point. मेरा L होगा consistent. Let's try. क्या है यार? After declaration specifiers. But this is return false. expected number name or this. I can just return. Oh. Can you hear me, Akash? By the way, I'm still getting an error. Do you know why? Any idea? Because I have pledged to not use ChatGPT. There is some problem. If a square is equal to the number, we return true. If not, then we change. I think we're just tired at this point. Why is it not working? Char 9 expected member name. Have I given an extra space? Return. Pause. That's correct. Then what is the issue? Yeah. I'm out of the while loop. Or should I just remove it? This was invented anyway. I don't need a condition. That's very simple if it's not. Oh, this is the thing. Return expected member name. What's the specifier? I'm not declaring any specifier. What is your problem, bro? I'm not declaring any specifier. Uh, what do I do with this? What's the issue? Should I just change it to long also? If it didn't work, I swear I would jump off a bridge. I think I should jump off a bridge. That would be better. Low equal to mid plus 1. Wait, why? How's that possible? Oh god, that was such a noob error. I should really just jump off a cliff, bro. Let's try. If it didn't work this time, if it didn't pass, yes, yes. See, it was so easy. I'm such a pro, guys. Just forget that I struggled even a little bit. Let's move to the next question. Heh, the essay. So new stuff. I'm done with the problem. Oh, let's make the notes of this problem. I'm not going to be a pro after doing all this, but do I care? What was the problem? Valid perfect square 367. Let's write the problem. What problem did I solve? Our approach was very simple. If we found the perfect square, then we return a true. And if we don't, at the end, we return a false. So approach is very simple. Let's just write it down. We use a low and a high variable and then run a while loop and we calculate mid in that. Calculate mid and square in that. How do we do it? We do low is declared as a 0, low equal to 0, and high equal to number itself, and mid equal to low plus high minus low upon 2, and we declare a long square because we want to bypass the overflow, and we'll just typecast our mid square into, we'll just write it to avoid overflow. So avoid overflow. Now that our variables are declared, and then we run a while loop until low is less than equal to high. Let's move further. After this, what do we do? If our square is equal to the num, we return true because it is a perfect square. If not, then we, but if not, then we update low and high to change the search space. What do we do after that? If our while loop has ended, if while loop ends and we do not, and we do not return any true, then it means number is not a perfect square. So we return false in the end. Very simple, guys. I think at this point I should just declare myself a master in this. How do I go back? Okay. And now we will write the code. Very simple code. That is perfect square. We'll just do Control C and Control V. We were not going to use any ChatGPT in this. And without using ChatGPT, I have solved an easy level binary search problem. Now I think Google would take me in. I think at this point Google should just invite me themselves. That, oh, please come and work for me, but they won't. Never mind. Let's move further. This problem is done. We'll definitely make notes for this one. Let's go ahead. First bad version. Let's check out the problem. What does the problem say? So the problem says you are a product manager. No, I'm not. And currently leading a team to develop a new product. Unfortunately, the latest version of your project fails the quality check since each version is developed based on the previous version. All the versions after a bad version are also bad. Okay, so whenever there is a bad version, all the versions are bad. What do we have to do? We have to figure out which version was bad. Apparently, that's what I assume. Suppose you have n versions 1 to n, and you want to find out the first bad one, which causes all the following ones to be bad. You are given an API, bool is bad version, which returns whether version is bad. Okay. Implement a function to find the first bad version. You should minimize the number of calls to the API. Okay. So is bad version function is given to us anyways. So what do? We write int low equal to 0. Oh, we are given an int n. Int high equal to n. Very simple. So while low less than equal to high, we can always check it in a linear time. But in linear time, the number of calls would be very, very high, and we want to reduce that. So for that, we are using binary search. Let's write it down. So while low less than high, what do? We calculate a mid. And mid equal to low plus high minus low upon 2. This function is just, this expression has been a muscle memory at this point. What do? We check if is bad version. If this is a bad version, we'll give it a mid. If yes, then what do? We check. We reduce the search space. We change low. No, wait a minute. If it's bad, then it means that we should update the high. High equal to mid minus 1. Oh, we should return an answer as well. Let's just assume that 0 is wrong. 0 is the bad version. So answer equal to mid, at least for now. If not, then we will just check it out. If not, else, if it's not a bad version, then what do? Then we update low. Low equal to mid plus 1. And what do we return at the end? Return answer. Let's check if it works or not. Oh, I wrote and instead of answered. I should just write an as. As. Looks so good. Because it's a bad version, so of course it's an as. Oh, I forgot to write an int with this. You see, even an as an integer. As is an integer. Oh. And let's submit it to check if it works. And it got accepted. Another problem added to our collection of binary search. The problem is called 278, first bad version. So easy problem. With solving easy problems. Uh-huh. Let's write down the problem. See, my friends, when you are trying to grow, and now let's write approach. Why is it not working? What happened? Okay, let's write approach. So, first, we declare variables. First, we declare variables. Which variables do we have to declare? At this point, it's just a muscle memory, low equal to 0, and int high equal to the number itself, and we will declare an answer, which will be the possible answer. Answer equal to 0. First, we just assume that maybe the first version could be bad. So if now we run a while loop, till when do we run the while loop? We run the while loop until low is less than equal to mid, whatever. That's very, very simple. We run a while loop. And if in which we check if our version is bad. If true, then set it as an answer and check the next one. Check the next one. We update the search space. If true, then we update the search space by updating the search space. And how do we update? Since if it is bad, then we will check on the left side. To the left side. And how do we do it? To change it on the left side, we do for searching on left, we do mid equal to, no, we update the high equal to mid minus 1. Minus 1. Simple. And if it is not a bad version, then we search on the right by updating low equal to mid plus 1. Simple. Now we just write the code. spell? Why is it JavaScript? This is C++. That's better. I'm done with only two problems so far. Three problems are done. Okay. This as variable looks so cute. For the first time, I'm complimenting some as, and that as is made by me. That's a variable. There are 329 binary search questions, and I have solved only four. See? With a 58% acceptance rate. Oh god, that's disgusting. First bad version is solved. Intersection of two arrays, valid, perfect square is already solved. Guess number higher or lower, binary search. Is this just binary search? Given an array which is stored in the an integer target, write a function to search target in nums. If target exists, then return it, otherwise return -1. At this point, I'm just, increasing the number of problems that I have solved. And high equal to nums dot size -1, while low less than equal to high, and mid equal to low plus high minus low upon 2. If nums of mid double equal to target, what do? We return mid. Else, if nums of mid is bigger than target. If it's bigger, then where do we search? If a number is bigger than the target, then we search on the left side. To change the left side, we do high equal to mid -1. Else, we just do low equal to mid plus 1. And if nothing is found, we just do return -1. This should run in one go, and it should pass all the test cases in one go. If not, then declare me gay. Haha, I'm not a gay. Oh, I was supposed to make notes for that. To practice binary search. Uh-huh. Binary search has to be the easiest algorithm. Low and high as low equal to 0 and high equal to nums dot size -1. I am taking a medicine. I don't get addicted to medicine, okay? Do you know that cough syrups have rum? And I'm not into drinking. High equal to nums, yes. And now we search. We run a while loop until low is less than, yeah, until low less than equal to high. Are you even? Oh, what's that oh means? I am 24. I'm not a kid. I just don't want to drink any medicines. Simple. In an while loop until low less than equal to high. If num, if num bigger than if num of mid bigger than target. No, if it is equal to target, we return mid, and if हाँ चलो बेटा हाँ चलो मेरा भी टाइम आएगा nums of mid is bigger than target. If it is bigger, then we will search the left side. Else, we search on the right side by updating mid. No, no, sorry, we update high. High equal to mid plus 1. The left side by doing low equal to mid minus 1. I'm chasing fake dopamine, bro. ये सारा कुछ आता है मेरे को आज ये चीजें करके आई एम सीकिंग ग्रोथ इसीलिए तो ग्रोथ नहीं हो रही है विकास कहाँ गया First we did binary search, then we did a search and circulation, then we did a square root of x, then we checked valid perfect square, then first bad version. Let's check how many problems of binary search have we solved. हाँ क्या क्या हाँ I will do a new question, a medium level problem. Let's check. अब मैंने ego पे बात ले ली है. Search in rotated sorted array. No, that makes me cry. Find first and last position of element in a sorted array. Find minimum in rotated sorted array. Find peak element. That looks like my kind of question. Let's pick it up. First, let me just do int low equal to 0, int high equal to nums dot size minus 1. I'm not a baby. Okay, so what do we do while low less than equal to high? First of all, what do? We check if our last element is bigger than its previous one, then obviously it's a peak element. Let's just say if nums of high bigger than nums of high minus 1, what do? Return. Do we have to return the element? Yes. Return nums of high. If nums of low is bigger than nums of low plus 1. This is called test case handling. We return nums of low. इसमें भी टेस्ट केस चली जाना चाहिए Else there is no, there has to be a peak element. If not, then return -1. This case would never work anyways. It is just for the sake of running the code and checking if my test cases are working. Ooh, that's so bad. Okay, let's check. Int mid equal to low plus high minus low upon 2 if nums of mid is bigger than nums of mid. This would throw error. I think I should make it this. Now it looks more like it. And now for low and high, let's change it. Low -1 to low and high +1 to high. High +1 and this as low -1. Mid and nums of mid should be bigger than nums of mid -1. What do we do? Return mid. No, nums of mid. Else, what do we do? Go on the left or right, however you want. Nums -1 equals nums and equal to -1 because the element is always considered to be strictly greater than the neighbor if that is outside the array. If it's negative, then we return -1. इसको पाप लगेगा, पाप बहुत बड़ा पाप लगेगा। मैं बता रही हूँ पाप लगेगा, एक और बार लिंक आ गया तो। क्या है यार, मैं स्ट्रीम Why are there 3 people on the stream? Who is the third one? No, it is only for the sake of consistency. And I'm already struggling and I don't want to struggle in public. People build in public. I am struggling in public. Can you please stop promoting my struggle in public? Why are there अरे यार गुस्सा आ गया, बेइज्जती हो गई मेरी, मैं स्ट्रीम बंद करके चली जाऊंगी। क्या पर्सनली भेजा था क्या?